All right, so today is the Inventor Jumpstart. This is an intro into Inventor. It's going over the basics. It's more or less to get your feet wet in the software and teach you how to get started with it. A little bit about myself. My name is Jeremy Gertis. I'm an application engineer with KETIV. I'm on the Lifeline support side. So if you call in with questions, problems, more than likely you talk to me or to one of my colleagues. I'm pretty knowledgeable with Inventor Professional, Inventor Sheet Metal, AutoCAD, and Vault. I came from design engineer and manufacturing engineering for 12 years, so I understand the practical use and the real world applications. So a little bit about the agenda for today. We're going to have an overview of Inventor. We'll do a guided tour. We'll take a break about halfway through. We'll continue with the tour of Inventor, go over a review of everything, identify some resources for you guys to continue learning, and then questions and answers. Always feel free to write a question in the chat, or you can raise your hand and I'll get to you as soon as I see it or as soon as there's a good time to get to the questions. Don't be shy to ask questions. Questions are good, helps us learn. So what's the purpose of this? It's to introduce new users to Inventor, the basic workflow. Inventor can be a very scary looking software at first, and for people that have no experience with any type of CAD software, or if maybe you're coming from 2D CAD or from another 3D modeling software. So a little bit about Inventor. It's one of the leading 3D mechanical design applications. Its main purpose is documentation. And you may not realize it, but you may say, well, I'm just creating 3D models, doing layouts. But that's documentation for parts lists, for BOMs, for machining parts, to source parts. It does simulation. You can do tooling design in it. And then it also does visualization, renderings, does animations. It's very powerful when it comes to those aspects of it all. Some of the additional functionality, and this is one thing that some people don't know about, but it's an extreme benefit. It has something called the Content Center that's downloaded with the software. And this is a library of parts that are created by Autodesk following all the ANSI and ISO standards for all your common components, I guess I could say, of bolts, fittings, hoses, tubes, pipes. And so instead of having to draw 8 or so different sizes of 1/4-20 hex head bolts, Inventor already comes with a library of those 3D models already. Then they also have what's called the design accelerators. This is a group of commands that lets you use the calculations built into Inventor to do gear drives, to do frame generation, bearings, and it uses all of the ISO and ANSI standards again to not only calculate what components you actually need for, we'll just say for V-belt drives, what pulleys and belts for the power transmission. It also has those models of those components built into the system. It does routed systems, tube and pipe. It'll let you route everything from flex hydraulic hose to rigid welded pipe to PVC. It also does cable and harnesses, does all your electrical runs. It also does the mold design. And then what's new in 2022, we'll go over a little bit of that. So the one thing that we always ask ourselves and try to figure out is what we've learned from partnering with all the manufacturing companies out there. What is their main concern? What is their biggest things that they worry about or look at? And we've come to learn that, the design data is probably number one. They want it to be secure. They want it to be organized, accessible, and dependable. And it all starts with doing good modeling to give you dependable, organized data and proper, paths to secure it and save it. Because nothing's worse than spending all day designing or working on a model to realize that, oh, you messed something up in the very beginning. Now the whole model needs to be reworked or is no good. Unfortunately, that does happen every now and then. And then we also learned that companies, the other big thing of importance to them are the people, the designers, drafters, and engineers. And keeping those people always learning. Because as I've said before, I've been using Inventor for probably 12 plus years for 8 hours a day, more or less. And I still learn and pick up new things all the time. It's an ever growing software. Autodesk is very good at adding new features every year and updating things to make it more user friendly. And it's gone a long way from, there are revisions of it to the year revisions, and it's continuously improving. And so it's always good for the people to continue to learn and continue to play with it to figure out new ways of working that may be better for them than what they were doing. So on this guided tour, we're going to go over some of the basics of sketching, of part modeling, of some assemblies, a little bit of presentations, and some drawings. And I always tell people the basics of any 3D, model that you're going to get out of Inventor, for the most part, it all starts with a sketch. If you're creating or designing it, usually it's going to start out with a sketch. And so you always want your sketches to be as accurate as they can be. Okay, and so today we're going to be working on this cylinder clamp. So we have the tutorial files here. I will send this link to. And you'll download the Inventor 2015 dataset tutorial files. Okay, so this is Inventor Pro 2022. And if you're on 21, 20, 19, I think 18, I don't remember on 18 or not, or before, but more or less this should all look the same. So we'll go a little bit over the Get Started home screen. This is there's a lot of information here, and there's a lot of useful stuff here too. So in the very top, just go over the basics. We can start a new file, open a file. We can save, got your, undo, redo, home. And then in the tabs here, the Get Started screen, or the Get Started tab, also has your new files, open, projects, open samples, home, team web, gallery, what's new, highlight new, help. You can go over your user interface, clean screen. You can switch documents and then the user interface layout. Oh, excuse me. Okay, so in this box here, we have new parts, drawings that we can one-click start. So you have part files. This is the backbone and the most commonly made thing in Inventor. It's an IPT file. It is your basic, single part that you created. Then you have your assemblies. These are where you take all your parts and create an assembly, an IAM file. And then you'll take your assembly or part and either put it in a drawing to give yourself, a dimensional drawing for it all. Or you can put it into a presentation to make an exploded view or an animation. So now let's get over to projects. This is something that we get a lot of calls about, a lot of questions. And so in projects, there's more or less two types of projects. I click projects up here. I can go to edit them. I can create a new project. You have what's called, the very top, it says type, single user, or you have type that's vault. So if you're working in a vaulted environment, your project is a vaulted project. You can set that up, or most companies already have this set up for their engineers. It's not something that, usually the companies, if they have a vault, they have a project already set up. So today we're just going to deal with a single user project. We're not going to go into the weeds of vault. But so on the project, single user, the location is where all the data is, all the files and stuff are saved, stored. So since it's a single user, it's all going to be on my C drive. And then you can also include different files and different folders outside of this drive for your project to look at. And then right here where it says use style library equals read write, if you want to change, all right, so for the style library, the big thing of that is if you want to modify any of the appearances, any of the sheet metals, any of the material, you have to be able to read write it to be able to save it. So you can have it read only or read write. So that's just something to keep in mind. If you make a new appearance for a particular paint color or powder coat color that you guys may use and it's not saving, it's more than likely because that you have it as read only. You can change it in that particular document, but you can't save it to your style library. And then we go down and we have appearance libraries. And Inventor comes with 3 out-of-the-box appearance libraries. These are the visualizations of the materials. I mean, you have everything from different types of wood that has the wood grain in it, to asphalts, to paint, to sheet metal, to rusted metal even. But if your company or if you have a custom library, you would add it here so it always populates in this project. And then again, we also have the material libraries, and Inventor does come with 2 built-in material libraries. And I mean, this has, I want to say, just in stainless material alone, I think there's like 10 or so different materials that are stainless steel. So there's quite a few in there. But I have seen companies that use a very particular material, so they'll have their own custom material libraries set up. And then workspace, this is a part for Vol. And then folder options, this is where your templates are for your part files, for your assemblies, for your drawings. And then you have your design data, that's all the calculations, stuff like that. And that's if your company's using a shared drive and not Vault for all your templates, all your calculations, stuff like that, this will all point to the same spot. And same thing with some of the presets and then the content center files. When you download the software, the content center gets downloaded to your local computer. But if you guys are using a shared environment and a shared content center, you guys will all be pointing to the same location. And then the options at the very bottom of it all, you have old versions to keep on save, and you can change that, and you'll see it you'll get a folder that says old versions. So once you save a part and then save it again, you now have an old version, because Inventor does not do backups in the way that AutoCAD does, where you get a back file. So you get old versions. And then you can enforce unique file names or no. I mean, that's completely up to you guys how your company has that set. And then the name of the project, this is the tutorial files, shortcut, owner, and ID. But you can see when I'm in the Vault project, I can add stuff to my workspaces, my work groups. And one thing that I get a lot of calls about is somebody would be trying to put a part or a pipe or a fitting or fastener from the content center in. They're getting errors like can't find content center library not loaded. And an easy way to check is make sure you're on the right project. If you come down here, configure content center libraries, you can see things that are checked are loaded, but if they're unchecked, it means that they're not loaded yet. So if it's not loaded and it's not red like this, you check it, it'll load it for you. And seen that a few times where people have accidentally unloaded it or gone from there. So that's the basics of the project. And again, that's usually set up by the company. So then going down, we have our recent documents. And this is very useful if you're working on the same assembly or the same part for a few days. Instead of having to open up that part and navigate to it, you can have it as a recent document, and you can change how it's sorted, what type of files you want to see, if you only want to see parts or assemblies. And you can pin them here, so if you know that this model I'm going to work with for a week straight, and then I know the next week I'm working on a whole bunch of other stuff, but I don't want to lose or forget where this is, I guess you could pin it and it will not leave the recent documents until you unpin it. Okay, so let's go over some of the basics of the parts. So I'm going to take the download zip file and I'm just going to extract it. So this is the extracted zip file. So since I already had this in here, we're gonna work on this cylinder base. There we go. Okay, so in your different types of your part file, your assembly file, your drawing file, and your presentation file are going to have different commands and tools that you can use. So if you're not seeing a particular command or tool, you could be in the wrong type of file. And let's open this up real quick, just like show you. So you can see here, if it ends in an IPT, that's a part file. And IAM is the assembly. And IDW or DWG is the drawing files. And an IPN is the presentation files. So in the part modeling, you have your 3D model tab, and yours might vary because I do have some different add-ins already installed, and all this you can customize to your part's content. It depends, if you use a particular command a lot, or if you don't use a command at all, you can have it. It's all. But with Inventor, most commands go from left to right. It's like reading, it goes left, right, top to bottom. So everything is going to start with a sketch, most everything. And you can do a 2D sketch or a 3D sketch. You have your create box. This actually creates geometry, 3D geometry. You can extrude. You can do revolves, sweeps, lofts, coils, embossing, drive, rib, decal, unwrap. You can do a shape generator. These are the work features. You can do planes and different ways to insert planes. You can do axes, points. Then on the modify, you can do holds. And these are, when I first started really, using this a handful of years ago, I didn't grasp quite what the difference between extruding a hole and actually using the hole command were. And then, after a few years of working with it and tinkering with it, the hole command has a lot of benefits over the extrude if you're doing a hole, because the hole command is smart data. You can tell it to either be a threaded hole, a countersunk, counterbore hole for a shouldered bolt. You can have it be tapered, a clearance hole. It's all information you can enter, and we'll go over all these when we make the part. You can do fillets, chamfers, shells. You can draft. You can add threads. You can combine two parts to create one. You can thicken and offset. You can split. You can do direct edit and delete face. You can also do rectangular patterns, circular patterns, sketch-driven patterns, or mirror. And then you have, create freeforms. This is something that I don't see a lot of people using, but it lets you start with a 3D cube or whatever shape you want and modify it from there. Then you have your surface commands. Then also inserting, you can do your stress analysis. And then also you can convert to sheet metal and vice versa. If we start a sheet metal part, we can convert it to standard part. So then on your sketch tab, you have lines, circles, all the different basic sketch commands. Then annotate, you can do 3D annotations on a 3D model. Inspect, measure, you can give the surface a different pattern if you have a complex shape that you don't know exactly, or sometimes, on a 2D monitor or monitor, it's hard to see particular 3D geometry. So sometimes adding some of these will let you see where the curves are a little bit easier. So then we get into the Tools tab. Again, we have Measure, you have Material, it shows the material that's used, and Appearances. We'll go over that in a sec. I want to get to Application Options. This is a big one because this is where you can change that Inventor as a whole, because then you also have document settings. In document settings, the difference between the two is application options covers all of Inventor, and document settings covers just that document. But in the general tab, you have your startup actions. So when I open up Inventor, I can have it set to open up a new blank template, or open from a particular dialog box. I can have it show commands near the mouse. And one thing I always suggest to people if they're learning or getting used to it is show tooltips. And what happens with that is if you leave your cursor over a particular command, it'll show you or tell you a basic, sentence or two description of what that command does. And a lot of times, people will forget what a particular command name is or what the icon looks like. So showing tooltips is just an easy way to constantly be cognizant of what's there. And then you can download help, spell check. It's always a good thing. The username, you can have the text appearance, change all that. You can change the undo file size, some of the dimensional scaling. And for the most part, a lot of these settings I don't change, or just because out of the box, they're pretty, for everything that I'm going to do, or even when I was designing stuff, out of the box settings were pretty spot on. There was only a couple things I would ever change. And then some of the save, you can change how long until it reminds you, hey, you need to save this file. And for some people, I would suggest that being shorter. It depends if they've had issues where things have crashed or the computer's running really rough. Saving it often so you don't lose all your hard work. Files, this is where you're going to point the projects to. So you want this to match what your projects are going to be pointing to. Colors, you can change the backgrounds color to from gradient to one color to different. You can add custom color schemes to just the visualization of the software. You can change the user interface to dark or light or even amber. On some of the materials that have a reflective, capacity of like stainless steel, high polish, or a mirror, they will actually show a reflection in them. And you can change what that reflected image is. Then you can also change your sketching colors. And you can change every color you want to whatever is easier for you to see, or, it's all up to you guys. And then display, we have some of the settings here for, what do we want the visual style to be? Shaded, realistic shading, shaded with edges. You can change that. And then the 3D navigation, you can do different types of orbits or however you want to rotate the part. Hardware. This is something I would usually tell people to keep this either on performance setting or conservative. Just unless you're doing the rendering aspect where you need the visualization, quality is going to tax the computer the highest. So unless you're trying to get marketing a rendered image of your model, or whatever the case may be, performance is usually the best bet. And prompts, you can tell it which prompts to tell you, which ones to ignore. If you know that you're always going to do a particular task, but you're tired of the system saying, hey, you need to do this, you can turn it off, turn it on. Drawings, the defaults for this are pretty straightforward. Notebook, this is something that I've only seen a couple people ever use. It's a powerful tool built into the software, but you can keep a notebook of the model, or an engineering notebook inside the model that goes over meeting minutes. If you're having a discussion with the powers that be and they say, no, I want to change that part to, we'll say blue, whatever the case, you can actually add notes into this notebook that's on the model. So every time you open the model, you can open the notebook and see what notes you have in there. So then we have some of the sketch settings. You have constraint settings. You have your spline settings, display, and then part settings, sketch on new part creation. Because when you do a 2D sketch, you either have to be on a flat surface or on a plane to start a 2D sketch. So you can change that so whenever you click new sketch, it automatically starts on the X, Y plane or whatever plane you would choose. Eye feature, we're not going to get into that. Then assemblies, you can defer updates. And with Inventor, if I have two parts that I designed and I make an assembly, if I change one of the parts in the part file, it'll update the assembly with the updated part. But if I have defer updates, it won't automatically do that. I have to actually, let's say there's an update, but I have to do that. And sometimes that's beneficial if you're working with very, very large assemblies that have sub-assemblies in them that are also really large and complex. I've seen where updating some of those sub-assemblies, when you go to open up the main assembly, when it tries to update everything at once, it gets really slow. So updating parts at a time tends to help. Trying to think what else is. The express mode, you can either open it in express or open it in full. If you're working with a particular assembly that has thousands of parts, opening it in express helps save some of the graphics while in the assembly. You don't get all the data, but visually it's all there. Or you can also open it full. It's completely up to you guys, but that's something that can help. And then this is the one that has been the most simple fixes to a lot of issues, is the content center. Since right now my project is a single user project, not a vault project, I can't check this, but I've seen this quite a few times where they'll have a vault project and their content center is in vault, but it's looking for it here in the local. So you need to actually select Autodesk Vault Server. All right. And so then the document settings, this is for the particular document. So for this particular model, I can change the lighting. I can change the way it displays. I can change the units of a particular drawing compared to my overall Inventor. Same thing with sketching, the modeling, bill materials, and some of the tolerances. Then you can migrate your settings. Some of the add-ins, you can load them or unload them. Depends if you're gonna, because I have cam loaded, but I can unload that so it boots faster if I'm not using cam. You can customize the dialog box, ribbons, you can add macros, you can edit. So we'll look here at the material. So the circle with the checkerboard on it, that is the material. And if you come down here to the bottom, since I have two libraries loaded in it, I have the Autodesk material library and the Inventor material library. So these are the different materials that Inventor comes, standard with. And then if I select Autodesk and open it up again, this is all the material that's in the Autodesk material library. And then same thing with the appearance. I have three. I have the Autodesk material and appearance, and then the Inventor. And you can see that, I have everything from whatever that one is to that's some really interesting ones. And so, and you can see here that you go, okay, this, I changed the appearance and it's not what I want. And I don't remember what the appearance for the stainless steel is. Up here, there's the clear. If you do select all, you'll get rid of that overwritten appearance. And the one that says adjust, you can select it and just tweak the coloring. But if you click the appearances, this is where you can add or customize particular appearances. And same thing here with the materials. So we'll go to the Manage tab. And this is what I was saying with the local update. You can update the assembly or part, depending if there's updates needed. Rebuild all, and then also update mass. You can set parameters. Style editor will let you edit any of the styles that are in the drawing or in the model that you're using. You can save them, update them, purge the ones that aren't used. You can create a derived part You can create a feature or place a feature. You can make components, make a part. If you're in an assembly, you can create a part. You can create a part in the assembly. And then some iLogic stuff we won't get into, and we won't get into the Content Center editing, but this is where you would edit the Content Center or publish and create new Content Center families. So then we'll go to the View tab. The first one is the object visibility. You can, turn off the visibility of the planes or the access, whatever you want. If you don't see or know which plane it is in the tree to turn off the visibility, you can do it this way. You can show the center of gravity. You can turn off the different zebra draft visualizations. In this one, you can do a half section view. You can do a quarter and a 3/4 section view. Visual styles, you can change it from realistic to watercolor. I usually will always work with the shaded. It's the easiest, no issues, at least taxing. You can turn on the shadows or turn off the shadows, and same thing with the reflections. You can change from orthographic to perspective. You can turn on the ground planes. You can change your, environment. Tons of different options. You can turn on and off textures. So if I had this material as bricks or whatever, the appearance will show bricks, and that's a texture, but I can turn that off. So, just to help improve speed while modeling. You have your user interface. You can turn on particular elements, turn them off. Then you have your navigate, but also here you have your view cube. And with your view cube, you can click the arrows to rotate it, 90s. You can do 45s, or you can click it and rotate it like that. And this, where it says top here, if you draw the model and go, okay, that's not going to be my top. I know my top will just say, I want it to be that. If you right click, you can set current view as top. And you can change all that. Then you can show the home view. And you can change that. You can pan. You can do a zoom all. Do a rotate. It'll spin on and center axis. And then the look at, I'll show you that. So if I click look at, and say I'm trying to draw something or model something on this particular angle here, but in my view cube, I'm not seeing where, to get that perpendicular. If I click look at, that now makes that perpendicular to the screen, and I could actually set that to the front. So if I rotate it, I'll be rotating it off that. So that's pretty helpful. Environments, you can do the stress analysis, the Inventor Studio, this is where you do the rendering. You can create the molds, BIM, Nastran, convert to sheet metal again. You can set it up to do the 3D print. It has that And then again, you have your get started, then add-ins and collaborate. And so we're gonna start creating this part. And so, I mean, if you look at it, and I've noticed with, just people I've worked with over the years that people will, or, 10 people will draw this probably 10 different ways. It depends, A, what is they're familiar with, B, what type of background they have. I mean, I used to work with some, very seasoned gentlemen that came from machining for 1,500 years. And if they were to draw this, they would draw a giant rectangle and cut things out. It's not necessarily wrong. It's just with Inventor, there's, hundreds of ways to get the same result. But so if we look over here, you have your file tree. And going down it, these are all the commands, features that make up this part. And then at the very bottom, you have end of part. If you click the end of part and drag that up, you can see what the first feature, what the first aspect of the model is. And if you right click and go to edit feature, you can see what that feature's dimensions are, what the particular commands are. Or you can also, edit the sketch of it. And, and you don't need to move the end of part to check any of that. But I'm doing this just so we can see how that part was created. And the one thing I always tell users, or especially new users, is you don't want to make any one particular feature too complicated unless you have to. I mean, if I look at the overall assembly here, I mean, I could probably sketch, quite a bit of this as maybe one or two sketches, but there's more likelihood that something gets screwed up, cattywampus. So you make it as individual components, break it down to the smallest feature you can, because then it's easier to edit the features and edit the sketches that way. So we're gonna create this. So we're gonna go to new, and we're gonna do a new part. Oh yeah, standard millimeter. Okay, so we're gonna start our 2D sketch, select our plane, and we come back here. We see that the first feature is a rectangle. And since this is in metric and I came from 10, 12 years of imperial, you have to give me a little bit of break on the, so I have a dimensional drawing off to the side just because me and the metric system don't play the best together. But I know that the rectangle is 160 by 86. So I could either draw, a rectangle, or if I come up here, and this is probably my favorite part in the sketch, and it took me the longest time to learn about it, but I go to 2-point center. So this lets me put a rectangular sketch on a center point. And as you can see, it snaps and that is the center point of the sketch plane. So now I enter my dimensions, and so it's 160. And if I hit tab, I go to my other dimension at 86. And now I have my rectangle. And you can see over here it says fully constrained. It means that nothing was able to move until I can't move or adjust any of it. It's locked down, and that's what you want. Let's show that. Because you can see here where it says one dimension needed, because this is able to move, and you don't want that. So once you get your basic sketch done, you can right click and go to finish sketch. Let's go back. I want to go with one thing I always forget. If you're having an issue with a particular sketch, if you're trying to extrude something or do something and it's saying that the sketch is not a closed profile, closed loop, if you right click, you can go to Sketch Doctor, diagnose the sketch, and these are the things that it's going to look for. And well, since this is pretty basic, but if you have an open loop, like if I drew this as lines and say I thought I connected it here, but I didn't, it'd say this corner is an open loop. So that's always pretty helpful. We'll go to finish sketch. And so the thickness of this, we're going to hit M for measure. It's 15 millimeters. So I'll come up here and come to extrude. And since I only had one closed loop profile in that sketch, it automatically selects it. But say I also had a circle or I had another profile, I would have to choose which profile to perform this extrude on. And I can choose more than one. But so we're going to say it was 15. I can change the direction of it. I can have it go the other way. I can have it symmetrical, asymmetrical. I can have it taper. We're just going to go basics for now. So that's our basic, rectangle that we start with. So the next thing is they have this dog-eared part, I guess I can call it. And let's see how they made that. I can click either edit sketch to edit the sketch, or if I just want to see what the sketch was, if I click visibility, it turns the visibility of the sketch on. And so that has benefits. If I create a sketch and I do a feature with that sketch, the sketch is used up. So you can't use that sketch again unless you turn it. You right click, you either hit share sketch or visibility to be able to use that sketch again for another feature. But so we see here how they did their sketch. Pretty basic. So we're going to rotate the part. And I can, since I can do a sketch on a flat surface, I'm just going to click, new sketch. And we'll just say it's so pretty much now I have a very basic part of my sketch. But with my dimensions and constraints, I can constrain that to what it's supposed to be. So I know that is 30 feet. And then I come to trim, I can trim the excess off. Yep, I knew it's gonna do that. Where is it? Okay, so yeah, on the dimensions, I can, when I go to dimension it, I can type in if I want to override the dimension, or in this case, since when I changed the dimension, put the 32 down, it automatically gave me a diameter of 32. So now it's giving me a radius of 16. But if I wanted to change that, you know, we'll say if I double click it, it'll let me add it or modify the dimensions. And then also, if you have too many dimensions, it'll tell you that you're over dimensionalizing the sketch and constraints. So you go, okay, I don't need that. So I can delete it. And so down here, I'll show my degrees of freedom. It lets me know what needs to be constrained so I can't accidentally move this or, you know, screw this up. So I can see here that I have something there that it doesn't like. So I can come here, select here. And now my sketch is fully constrained. We'll go more over dimensionalizing the sketch in a little bit with some easier, but I want to get the basics of just the sketching. And in the circles, you can do tangent circles, ellipses, and arcs, different ways, different types of rectangles. You can do your slots, you can do polygons, you can do fillets, you can add text, you can add points, trim, extend, offset lines. You can do patterns, some of your different constraints. Excuse me. Parallel constraints, tangents, perpendiculars. Excuse me. Okay, so we're done with our sketch. If we come back here, see how thick it is. So that's 18. And you can see here that it's projecting off the geometry. You know, that's not right. So if we flip it, it goes the other way. We know that needs to be 18. And on the distance, you can have it do a through all, or to a point, or to the next. In this particular example, it's not going to work, but I will show you that with a couple of cuts we'll do. So we have our basic dog ear. Okay, so going back to the part and seeing what they were doing. They added a fillet here. And so I could have put that fillet in the sketch, or what I would like to do is chamfers and fillets. I add those as features and not part of the sketch, because if those change, it's just easier to edit one of the commands instead of a sketch. So I'll come here to fillet. I'll select that corner, and it is 8 millimeters. So I can also turn off the visibility of the sketch because we don't need it anymore. So the next thing they did is this hole. I'll do that later because I want to show you an easy way to duplicate the geometry. So since I know that my feature on this side is going to be identical to this, I can either sketch a completely new profile and extrude, or I can mirror it. But with the mirror, I do need the center work plane. And since I started my sketch, in the center of the work planes, I expand my origin and click visibility on that plane. This plane is in the middle of this part. So if I come up here to mirror, I can either do features or I could do solids. In this case, I'm going to do features. So I'm just going to click, click, or I can click them on here. Then I select mirror plane, hit OK. So everybody see how to do the mirror? Because that's really beneficial. If you have a lot of the geometry done for one sketch, it makes it easier instead of, redoing the sketch or creating a new sketch. It's a quick, simple way to duplicate it. So then we'll go back and okay, so then they added a hole, and this is the hole command we'll go over. So I can either start a sketch here. I'll show you both ways of doing this. So I can either put, 11 millimeter hole there and extrude that. So I'm going to flip it and then make sure it's set to cut, or I can have it join, but we're going to cut, and I can say through all. And that puts it through any part of the part that's going to be in the way of this. So that's one way to do the hole. But we'll say delete that. We're going to delete the sketch that was used to create that. But if I come up here to the hole command, this is the dialog box that's going to pop up. And I can either have a clearance tapped. We're just going to say a simple hole, pick a face. And then you need to pick where it's located. So when we click that radius up here, it centers it on the hole, and then the size of the hole. It's 11. And then termination, I can give it a particular length, but I'll again say through all. So two different ways to create a hole. Okay, so the next thing we see is they created this little tab here. Let's see how they created this. So we can see that they created this profile. But I can create the same geometry by doing a sketch of, what is it, 19 by 14. And then I'll just drag this onto the model. And then I'll come up here with my dimensions, my dimension tool. And I can see that this tab is flush with this surface here. And I can see from this edge, it's 13 millimeters away. So if I click my dimension, I can click this line here, it's 0, and that brings it to that edge. And then same thing on this side, 13. Let's say that that needs to get moved over. I can change it to 15 or whatever the case may be. And to change the dimension, I click it and it'll let me edit. So we'll say finish sketch. Then we'll extrude it, and that is going to be 34.5. No. What is that? Metrics. Measure from there. 19.5. And say you don't know what the dimension is, or you're trying to figure out what roughly is going to fit best, you can grab the arrow and manually drag it and place it. Okay, so then when we look at our part, it has a radius. So we'll come back to fillet. Like this. And its radius is 9.5. So there was a different way to create the same feature just in a different set of steps or a different process. And that's what I mean by there's tons of ways to create the same things. It just depends what you're more comfortable with and what you're used to. Okay, so we'll see what's next. I think it was that hole. So they added another hole here. So we can click the hole command, pick the base, then the location, makes it concentric in that radius, and the diameter of that is 8. Okay. So let's mirror this feature over again, so we don't have to create a new one. So again, we just create a mirror, and we're going to do the features. So I can select the features from here, or I can select them from the tree. It just depends. Sometimes it's not easy to see or grab the parts without grabbing extra features. Sometimes it is. It depends on what's the best for you at that moment. Click your mirror plane. So now we have our 2 little tabs with holes. So the next are going to be these chamfers. So we'll come up here and start our chamfer command. And in the chamfer command, there's 3 different ways to do it. You can do a basic chamfer that's just a dimension. You can do a chamfer with an angle and a dimension. Or you can do a chamfer with 2 dimensions. So we're going to be using this one. So I first select my edge. And my first dimension is 13. My second one is 40. Hit OK. Then go to do another chamfer. And once you complete a command and actually, hit OK, apply, the next time you start that command in the drawing, it's going to remember the inputs that you used last. So it's automatically opening up to the 2 distance, and it already has my dimensions in there. I put it on and go, okay, but those dimensions need to be changed. So I could change the dimensions, or in a lot of the commands, you'll see this flip arrow, and it flips the 2 dimensions automatically. So before the flip arrow, after the flip arrow, hit OK. So now we have our 2 chamfers put in. And we'll see what, those ones. We'll do these 2 holes now. So when I go to place a hole, pick the surface. Now, since I don't have a centric to go off of, I need to select 2 dimensional locations for it, 2 edges, 2 planes. So I know from this edge, it's 33. And then from this edge, it's 0. So again, 33. And you'll be tempted after you enter that first one to just hit enter, but you need to select both locations before you do that. I have my two holes, and then if I look at it, something doesn't look quite right. I go, man, those holes look a lot larger. So if I need to change my hole size, instead of having to go in, if I did this as a sketch, I can right click my hole, edit feature, change that to 11. Okay, so now we're gonna go and put this. We'll put this countersunk hole in next. So again, come back to hole. Select the face. And then I know from here it is 16. And then from this edge it's 43. And it's 16, 4, 11. All right. And say, you know, well, we're going to change the fastener to a different diameter of a head. We can easily change that instead of going back into a sketch if we would have done that as a sketch command. So that's the benefit of using the hole commands for sketches for create holes. All right. So next or last on this part are going to be these holes up here. So we can look at the sketches. You got to create some interesting sketches to be able to get this geometry. So how do you create a sketch on a round surface? You need a plane. So I can click on a let's get rid of that. So if I click plane and I click perpendicular surface to where I'm going to be working. So since I know that I want my plane in that same, I just click here, click it. It lets me put a plane there. And say I want a plane in the middle of this part. I click this face, puts a plane there. We don't need that. So we're going to start a new sketch up here. And so we know that the holes are going to be in the center of these parts. So what I like to do is go up to project geometry. And what project geometry does for you is if you have a sketch there's geometry or features under it, the project geometry brings those features to that sketch. So just straight looking down, I can see that there. And then what I would do is start a new line. If I right click, hit point snap, hit midpoint, it'll automatically make sure it goes to the midpoint. And you know, most time you can tell when it snaps to the midpoint, but in cases like this where it is on, you know, interesting geometry, I will like to make sure I say, you know, I want to be the midpoint. Okay. And then what I'll end up doing is adding a point to the middle of this. So again, midpoint. Midpoint. Finish 2D sketch. Now when I do the whole command automatically grabs sketch points to use. So if you have any sketch points, it automatically throws holes on them. And we can deselect or select them and vice versa. But we know that this is a tapped hole. There's no seat on it. But we know this is goofy metric thread. And the size is it's M6 by 1. And so we can either have the thread go all the way through, or we could give it a set distance, or we could say 2. So we select 2, we select this face, hit OK. And you can see that it gives the representation of threads. And a lot of people ask and say, well, okay, that it shows threads, but they're not threads. And you can model 3D threads. I would usually suggest against it unless there is an absolute must or reason, just in the fact that that burns up a lot of, the power. The threads, when you do this or add threads, the system knows what type of threads they are, and it's able to call them out, and all the geometry form is correct in the model. So even though the representation of them is, doesn't give you the actual lips and parts of the threads, they are threads in the system. So we can turn off this plane and say, okay, we created our part, and say we want to make this out of silver, because doesn't everybody want a silver cylinder clamp? Or whatever the material is. We can change that before or after. And you can see changing the material changes the appearance. Unless I come over here and change the appearance to something else. And then the appearance, since it was overridden, stays at whatever I selected, even if I change the material. So if you're changing the material, you're like, well, why isn't it showing a new appearance? And it keeps it stuck on this. One thing to always check is if you have a little star next to the name, it means that's overridden. If you come up here to the clear, select all. And then it goes back to following the material. And then also in your part file on the top of the tree, if I right click, I go to my eye properties. This is where you can add different information. This author part right here, this is pulled from the application options where I have my name at. You can enter part number, descriptions, costs, different information into the properties that stay with the part. Different, statuses of if it's approved, not. You can do custom properties. You can, how you save the thumbnail for it. And then physical, if you want to figure out what the mass is, what the volume, what the area of the part is. Since it's polystyrene, if I click update, it's going to say it's 0.307 kilograms estimated mass of that part with that material. And we'll say it's steel. Go back into our properties and see it's now 2.3. So the material itself changes the properties of the part. I'll just go back to, so we'll just save this part, go to File, Save As, Cylinder Clamp. We'll just say this is test 1. Save. So that's the basics of creating a part. Is there any questions on a basic part before we go on to the assembly and drawings? All right. So it's 10:03. Get going on assemblies here now. So let's open up our assembly and see what's. Let's close this. Okay. So this is the assembly we're going to start creating. And with assemblies, the biggest thing that I can say for points to remember is the first part that you put down, most everything's going to build off or constrain to. So I would always suggest that the first part you place be more than likely either the largest component or a part that you expect will not change. But so we're going to start up a new assembly. Do a standard. So in your assembly file, you have different tabs than you did in your part file. You have the assembly tab first off, and in the component part, you can either place a component from your libraries, or you could do place from Content Center. And these are all the parts that are in the Content Center as a out-of-the-box standard. You have bolts, a plethora of different types of bolts. You have the captive nuts, hex nuts, tons of those. Pins, rivets, washers. You have shaft parts, bearings, clips, collars, thrust washers, sheet metal, fittings, there's tons of stuff built into the Content Center. Okay, and then you can also place iLogic components, place from electrical catalogs. You can create a new part in the assembly. You can move, rotate. And then join and constrain. You can join two parts or constrain. Constrain's the most used in the assembly for attaching parts together. You can show the constraints that are in use or hide them. You can do patterns. You can see your bill of material. You can do parameters. You can create I parts or I assemblies. You can create drive substitutes. And again, you have your work planes, because sometimes you can't constrain something to a part. You have to have a work plane or an axis to be able to find where it's going to constrain. And then you have simplification. You can create a simplified part, simplified view. And then in the design tab, these are where those design accelerators are that I was talking about. And you can only access these in an assembly drawing. You can't access them or use them in a part model. It has to be an assembly. But you can do bolted connections, and you input some of the data for what the forces and torques are going to be, and it'll calculate what bolt, what size, all that. One thing I've used for quite a while is the V-belts. So you can, we'll just say real quick, select that plane if this was, but it automatically puts in, pulleys, and I can adjust the size of the pulleys, the RPMs, calculations like that. And then I can check for strength to say, okay, at a 14 horsepower, it's spinning at 340. It'll tell me that this size of belt is not going to be adequate to the standards that I need. So I need to increase my belt size, increase the pulley sizes for RPMs. You can do shaft design. You can do gears, do bearings, keys. You can do chain drives and synchronous belts. You can do disc cams, O-rings, and springs. And these are very powerful tools that are very easy to use and help speed up the process of your design. But yeah, to be able to use the design accelerators, you have to be in an assembly. And this is also where you do the frame generator. And then again, you have 3D model tab if you're creating a part. Same with sketch, annotate, inspect. You can see if there's interference in parts, tools, manage, view. I don't think there's any other changes besides the assembly and the design. But so on our assembly, we look over here, it's an IM, so it's an assembly. And we can see our first part, it'll have a little pin in it. That means that it is pinned, it can't move, it is locked in place on the drawing. So that is the cover front. So we're going to start our new assembly. Select the part we're going to place. And before we click anything, if you right click, then do place grounded at origin. That grounds the part at the origin plane. So even though I can rotate the whole assembly, I can't move the part in relation to the planes and to the origin. So we'll place some other components so we can start building off of it. So you can see here, since this part's not grounded, not constrained, it moves all over the place. So if we look back on the cylinder body. So when you insert the parts, you can, insert more than one at a time. Or when you're inserting them, say that, I have a whole bunch of cylinder bodies that I need to put in. I can keep placing them until I hit escape. And I can just delete the extras. So if we look at our assembly here, we see that the cylinder body is butted up against this face, and it's concentric around the machined part here. And same thing with the back plate. So I could easily constrain the front and the back off of each other, or I can constrain the body to the front and then the back to the body. It all just depends on what's easiest for you, what you're able to do. There's sometimes where I can't, or I may not have my cylinder body, done yet, but I know what my general dimensions are going to be between the two, so I can constrain it that way. But if you click on a part, hit G, you can rotate it instead of rotating the whole model. And so if I hit C, it's for constraint. And with the constraints, there's quite a few different options and tools to help you. You have a mate, which is the most basic, most commonly used constraint. And it'll let you constrain faces together, edges together. Then you have an angular constraint. You have a tangent constraint, and then an insert. I like insert the best for anything that I know is going to be, that is, concentric to another round object. It can be, doesn't have to be circle, or doesn't have to be full circles. It can be radiuses, stuff like that. But as long as it's concentric. So what you do is you first select one point, and in the selections, if I click one again, it lets me reselect it. Doesn't matter if I click the outside or the inside. Then my second point, I select down here, automatically makes it concentric on this machined part. Let's say I had an offset where it wasn't actually all the way against the face. I can type my offset into it. But we know that's not, so. And then same thing on the back side. One second. So now, as I can see, I still have, rotation here, which I want to get rid of. So I can start a constraint again. I can do an angular constraint and select this face and this face. Come back here to a directed angle. And it keeps those both at 0 degree. Or I could come in and do a mate constraint as a flush. So that's what I mean why there's plenty of ways to accomplish it, because sometimes it'll work for what you're doing. Other times you have geometry that doesn't work in that particular instance. So then all we need to do is constrain our cylinder body because it's able to still rotate. So if we open it up, we go into its origins and it has its work planes. And you can use those to constrain. So again, we'll start an angular constraint. So now we're all constrained. I'm going to turn off that visibility of that work plane just because I don't see it. So what else do they have? They have bolts and washers or nuts. So let's add those. So in this instance, when I constrain this part, I want to know how far out the edge of this threaded rod is sticking through. So I'll measure from here to here, 5.5. So I could either do another insert and change the direction, put 5.5. And then all I need now is my angular constraint to stop it from rotating. But say, I don't know what my distance from the edge of the threaded shaft to this face is. I could also do a mate constraint by selecting the circle and selecting there. So then I would have to also constrain that side and then the distance. But if I constrain it like that, where it's two axis constraints, I just now need my distance from the face to this edge and then an angular constraint. So there's, different ways to accomplish it. Okay, and so now we'll turn on the plane so I can get that locked down. So next we're going to put on the nuts and go back to an insert constraint. When it comes to the pipe fittings, hose fittings, anything like that, the insert constraint I use the most because it takes away a step of also having to give it a distance constraint. So I'll select here, select there. If I hit enter, keeps the dialog box open so I can go to another component and come here. Now if I go to the angular, click there. So I have that fully constrained down. And I could easily put the parts, put 4 of those shafts in and put the rest of the nuts in. or I could create a pattern. There's benefits to both. It depends what you're doing, how you're doing it. In this case, I know that nothing's going to change, so the pattern is just fine. So I come up here to rectangular pattern, pick my components. Then I need to pick a direction. And then I need to pick a distance. So let's see what it is from center to center. So from center to center, it's 39, and I believe it's 39 down too. So come back here, back to pattern. So this is the distance. And say that I needed 3 of them. You know, it would give me 3 in that particular direction. But it's only 2. Then we'll go the row, 39. And it's the wrong way, but we could flip it. Or you could put negative 39 there. Okay, so now we have our components patterned in the assembly. Okay, so next, let's put the piston and, okay, got it. So let's grab the piston and all the piston parts. So you can you can create a small subassembly or constrain parts together that aren't constrained to the main assembly and then constrain them to the main assembly. So in this instance, what I'm going to do is constrain these 3 parts all together and then insert it into this main assembly. So then I'll add my nut, hit OK. Let's add some angular constraints to all that. And since we're going to be constraining this, you can turn parts, turn off the visibility. This way you can access, what's in the middle of them. So if I look here, I can see that my piston, if I expand it, I can see what constraints are attached to it. So I can see on this mate here, I go to edit, it has an offset range. So it has movement built in. And I'll show you that. This one, 35. Okay. So the first thing I'm going to want to do is constrain this piston rod in the center of this hole. So I'll click there, click this axis constraint, flip it. Okay. And I'm going to turn off the visibility of this body. Just right click it, click visibility. And if I start a constraint again, click there and there. If I wanted to have, a travel, I click maximum 35. minimum 0. So it'll let me actually, move the part. Make sure that's not, yeah, it's 35. Okay, so go back and we're going to give this an angular constraint so it doesn't rotate on us. And then for this part to actually, in its subassembly, it'll always have this ability to move. But once you put this subassembly into another assembly, it'll lose its ability to have that movement unless you turn the parts into contact sets. I'll show you that. So make sure I'm going to grab all the right parts to do that. Yes, piston and that one. So if I right click it, click contact set. Same with this one. Same up here. This will let that movement, this travel, stay in another assembly. So since we got, everything all pretty much bunned up, we'll turn the body back to visible. So that's our basic of our subassembly right here. So let's save that. Okay, now let's open up the main assembly. So you can see in this main assembly, it still has that movement in it because we turned those into contact sets and we enabled the flexible option. But when we look at this assembly, the first part down is going to be the base. So we're going to start a new assembly. Go to place cylinder base, then click place grounded at origin. And we're going to say that I know that's going to be my front. So if I come up here on my view cube, right click, set current view as front. I know if I ever click on front, that's what it's going to be. So now let's add the rest of the parts. So the next thing we're going to add is the cylinder body assembly. Okay. And let's measure, because looking at this, since I know that it's going to be, aligned with these mounting holes back here, that's how I would start with my constraints. So I want to measure from this face to this face, and it's 0.5 millimeters. So if I start a constraint, go to insert, select there, and then I said 0.5. All right. And then to keep that flexibility, I need to come in here and make sure it's clicked as flexible. Because if it's not turned on as flexible in its parent assembly, it will lose that ability to have that movement in it. And you can see when I do move it, some of the bolts get a little haywire. And that's just with the way that they were patterned. And once you finish the movement, they go back to where they're supposed to. So let's add another part to it. And the next thing they added was the clamp. Let's just see if there is any offset. I don't believe there is. Yep. So go back to place, clamp. Again, if I just hit G on the part, I can rotate it. So I can just kind of get a better understanding of where it's going to sit. Hit C for constraint. Go to insert. Place it there. Then if I constrain it again to there, select that or this axis and that one. Hit OK. And it lets it have that movement. So then we have some of these shafts that we need to add. And then long shaft. So I could, when I put these shafts in, I could either figure out what my distance is there, 5, or since I have a plane in the middle of the part, I can constrain it off another plane. But since any of these inserts are, I found easier and quicker to do an insert constraint. So flip it and say it's 5. And you go, okay, well, that went the wrong way. If you put a negative in front of it, it goes the other way. So now let's figure out what that short clamp offset is. And it's 4. So we have our 2 pins in. See the other components that they added. Okay, they have lock pins, they have clips. Check to see if there is any offset here. Oh, there is. So it's 1 millimeter out. All right, so we got our lock pins placed. And then next, we'll put the there we go. So now let's put the clips in. Place clips. make this flip. So, and again, you can just constrain these. Like so. And then if you don't know what exactly is moving, or if you want to make sure everything's locked down, you click degrees of freedom, it'll show you what still has movement or rotation in it. So, and up in the upper right, you'll see this, on my screen right now, it's a gray, plus sign. When that's red, it means that one of the parts or something has happened to the model or the assembly that has created an error. So if I went in to this subassembly and I change some dimensions on something and I have a constraint based off something that got changed, it'll tell me, hey, you need to update this assembly, you need to fix it, there's something wrong. So whenever you see this design doctor get red or turn red, it means that you have an issue, and I would always suggest looking at that and trying to fix that before you get too far, because sometimes the errors that you're working on top of give you enough nightmares down the road where I've seen people pretty much have to start over an assembly or a model that they've spent hours to days working on just because the base features or base parts had issues. So that's the basics of parts of the assembly. And then, if I go to my BOM, shows me my BOM, I can see all the parts in it. I can go into my environments and, if I was going to do rendering, I can start Inventor Studio. I could change the lighting to my heart's content. I can render image, actually renders it. I'm not going to go into that. That can take up some time. It's not necessarily a quick process. But does everybody get the basics of the assembly part of it? Any questions on assemblies before I go into drawings? Okay, and I will also, after or at the end of this, I will email or I will send my email out in the chat, and guys feel free to email me if you guys have questions, and I'll either get them answered, or if I need someone else to answer them, I will make sure that you get your questions answered if there's something that you wanted to see that we missed. Okay, so now let's go into my drawings. Okay, we're going to start a new IDW. And since I don't have a model open or an assembly open and saved, when I go to base, just to put the base view down, I need to select a model or an assembly to go off of. Let's say I actually am working on cylinder. Say I'm working on making a drawing for this cylinder clamp. When I go to drawing, now that I have that open, I go to base, it automatically pulls in whatever model or assembly was last opened and or what is open and what was last saved. So if you have 3 or 4 models open, whatever one was the last saved, it's automatically going to pull. Or you can come up here and choose a different model. So when you go to place it, your drawing view, you can change the model state, you can change the design view. You can have it show hidden lines, no hidden lines, or shaded. You could change the scaling here. You can change which parts of the model it's going to show. If you have parts of the assembly that are reference models, it will not show those, or it'll show them differently. Depends how you have it set it up. You can have it show the threaded features, tangent edges, interference edges. And say I want to show this side using my view cube, I can select what side my first place is going to be. Let's say we want to start with that. Then I'm going to have it projected here, here, there. Then right click, hit OK. Then I can also move them all together. And the ones that are projected will only move to what their projected view would be. But my base view, if I move that, all my projected views will move along. My isometric just kind of does its own thing. So now we have our base, drawing there. So if we go into annotate, we can do a parts list. So say I want to do balloons to call out a parts list. I can come up here and create individual balloons, or I can do an auto balloon. I'll select my view, then select all the components, select placement, hit OK. And then since I did not have my BOM view enabled, just says, do you want to enable the BOM view? Yep. So now if I go to parts list, I can select this view, click OK. So there's my parts list with my ballooned items. I can change the numbering, do all that. And let's go to just a single part. So say I wanted, where is it? So we're gonna do just this, base part for dimensional. And I go, okay, and I can change my scaling. I can enter custom scaling, move things how I want, or vice versa. But say I didn't put this view up there, I can come here to projected view, select, bring it up, do that, hit create. I can do section views. I can do a detail view, an overlay. I can slice any, most of your, or all your basic CAD drawing views, they're all in here for commands. But the nice thing is when you come to do your dimensions, you can start dimensioning it by hand, however you want. Or you can come up here and do retrieve model annotations. And any of the dimensions that you use to create the model will be brought into this drawing. So first we're going to select a view. Hit OK. So these are all the dimensions that it brought in that we used to create it. And I can move them. Delete them. So I could quickly and easily dimension my model from the dimensions that I already used. And then for my hole and threads, I can compare. And it calls out it's a through hole. And on this one, okay, it'll call out what type of hole, what type of counterbore, the depth of it. And then same thing with the threaded hole. It calls out what its threads are, what its standards are. So that's quick ways to get your standard, hole dimensions into your model without having to type in, this is a M6 by 1 threaded hole. You can add text and notes. You can add different block tables for revisions, notes. You can change your sheets. You can edit the sheet, change the size. A lot of this stuff is another one of those things that's usually set up and controlled by the company because they'll have their title blocks already in the system. They'll have their dimensions, their styles already there. But then, we can add our center marks for our holes. We can add the center lines. So it makes it quick and easy to actually get your dimensionalized drawing done and ready to go. We'll go back and we'll auxiliary view is a view that'll let you take it off of an auxiliary face angle. And sometimes you need that to be able to call out a dimension or a feature that's on one of these faces. So you'll select the view, then you'll select, and it brings it off of that. And then, yeah, that's really it for the drawing. The drawing's really similar and basic to if you've used any of the CAD softwares. It's, you have your symbols, you can do leader text, your baseline dimensions. You can add sketches to the drawing. You can hatch, do different things. In this one, let's go back. The view. I can edit a view and say that, I want it shaded. It'll actually give me a shaded representation there. So if I right click, edit view, on this one needs to be the base view, not the projected view. And say in this drawing, for whatever reason, I don't want to show this clamp. If I open up my base view, I come here to the clamp, turn off its visibility, it'll no longer show it. And same thing, just turn it back on. So sometimes people will do that if they need to show things behind it or different. I've had quite a few customers who use that for different reasons, and it is helpful if you don't need to show particular things. All right. So let's cover quickly the presentations. So let's close all of this. Let's cancel because I'm going to use that. So now we're going to start a presentation file. And so it wants me to insert a model. So I'm going to put cylinder clamp. So tweak components is what you would use if you're creating an exploded view. So you select the component and we're going to say it'll be this subassembly, and I'm going to bring it up here. I can show the trails or not. It's up to you and the company. And hit OK. I can tweak this component. And say it comes out here. Hit OK. And so it'll let you create your exploded view. Then you can save that, and you can create your drawing view. So then you can insert your presentation view in to do an exploded view with parts list. So it's a different way. And then one thing that I wanted to cover before we start running too much out of time, I get a lot of calls and questions about like goofy issues or errors in the system and software, and a lot of people don't know how to check to see if their software is up to date or if there's updates that are needed or how to do that. And one thing that you can always check is up in the right corner, you'll have this little question mark and a down arrow. Click the down arrow and click About Autodesk Professional. It'll tell you the build number and the release. And my release is 2022.0.1. And I can look up and see if there's any updates that, are past this and install updates. And usually the updates will fix a lot of the goofy little issues that come up over time, because Autodesk is constantly looking for issues that arise in the software. And so a lot of people will ask, well, how do I get the updates or how do I install them? I'll bring this up here. And one thing I always tell people is when you download the software, you'll download the desktop app. And the desktop app is great for updates. I wouldn't suggest ever downloading, software from it, just because the way that the software downloads, it takes a lot more, internet resources doing it this way than others. But if you come over here to updates, it'll show you any available update for your software that you have installed. So I have 2 updates for 3D Max and for Revit. So this is where I would usually install my updates. Just a helpful little tidbit there. And then you also have your account. Most people now are being switched over to single sign-in user because there's a network license, a single sign-in user, and then there's the maintenance activation, which that's pretty much gone now, and network's even kind of going away. But if you're not too sure what type of license you have, you can always click on manage license and it'll show you, commercial, that is the single user sign-in. And you can change your license type. So if you guys have network license and you're going to single user, you guys already have the software purchased, you can change it before it runs out, save a little headaches. Okay, so let's close that. Okay, let's go back to there. I want to go over some of the. So there's plenty of other learning resources if you guys are just getting started. There's tons of online help. There's the Autodesk Knowledge Network. This is a great place for, learning, for troubleshooting, for tons of different, avenues. Send that link out. And then there's different, the Design Academy is a whole bunch of short, quick videos on how to do certain aspects. Send that one out. Then we have the KETIV AVAs. This is a weekly thing where we do 30-minute, 45-minute, deep dive into particular topics that are questioned or asked a lot of, how do we do this, or people want to know more about specific things. So like tomorrow we're using custom user coordinate systems with assemblies. I mean, that's very, in-depth, niche part of Inventor. So if you guys are interested, you guys can register to watch that. It's a quick little video and, lots of information. We also do Fusion, where on Fridays they do a Fusion, 30, 45-minute detailed part to help people with Fusion. And then if you ever need to get in touch with us, you can always reach out to Lifeline at KETIV or give us a call. You know, we're always, or not always here, but we're here, you know, Monday through Friday. And, you know, always helping. Anybody have any questions on anything that we went over? We'll get wrapping this up here relatively soon. And I also just sent out my email address if you guys have any questions or comments about the presentation or about what we went over, or if you need any further information, feel free to shoot me an email and I'll get back to you as soon as I can. Well, alrighty guys, I think that'll be it. And thank you for attending Inventor Jumpstart today.